So here is the definition of a hyperbola up here at the top of the page. And again, it's the set of all points in a plane such that the absolute value of the difference of the distances from the two fixed points is constant. And again, those two fixed points are called the foci. So each one is a focus point. Now let me show you some key differences between the hyperbola equation and the ellipsis. So if you remember, the ellipsis equation in between the two fractions, this was a plus sign. So in the hyperbola, it's going to be a subtraction sign. They're still both going to be set equal to 1. Now, the key difference also is, remember, the a squared and the b squared switched in the ellipsis. Now what's going to happen is the a squared and the b squared stay in the same spot. What's going to move is going to be your x squared and y squared. And whatever variable you see in the top of the first fraction, so up here, this is going to tell you which axis it touches. So notice I see in this standard form, I see the x squared first. So this is going to tell me that when I go to graph my hyperbola, it's going to touch the x-axis. And it looks like this over here. When you see the y squared first, like on this one, this is going to tell me that when you graph it, it'll be the u in the upside down u. It's touching this y-axis. So that's going to be the key difference. You're going to have a subtraction sign in between the two fractions, and that what's going to switch is the x squared and the y squared. So that's a key difference. Another key difference is when we start to calculate the focus point. Remember, the equation for the ellipsis was c squared equals a squared minus b squared. Now, when we talk about the hyperbola, what's going to be in between here is a plus sign. So really what's happening is in the equation, it's going to change from a plus to a minus, and then in the c squared equation, it's going to change from a minus to a plus. So the minus and the pluses are switching places. So those are the key differences. Go ahead, and this is also just the same thing I just showed you, but I hand wrote it. So again, notice this first equation here. Notice the x squared is first. So this is the one where the graph touches this x-axis. So it's the c or the backwards c, or both together. Then this one, the y squared is first. So this one touches the y-axis. So it's the u and the upside down u. Another thing I didn't talk about on the other slide were asymptotes. So down here, these are our equations for our asymptotes. Our asymptotes are going to be linear equations. So when the x squared is first, your equation for your asymptote is going to be y equals plus or minus b over a. And we're going to get this b and a after we square root the a squared b squared. And then when the y squared is first, then the equation is going to be a over b. Think about these two asymptote equations as equations that are in y equals mx plus b form. In this a over b plus minus, or b over a, that's going to be the slope of the line. So we're going to be graphing the pink lines, and those are going to be our asymptotes. So when we go to create our graph of our hyperbola, we're going to calculate the focus point, the vertices, and then we're also going to be graphing the asymptotes. Now, when we did the parabolas, we had to find additional points on our parabola. We're not going to do that for the hyperbola. All we're going to do is graph these two lines, and they're going to be like the walls or our guidelines of how we're going to make our C shape or our backwards C shape. So we're just going to graph the vertices, and then from there, make our U or our C's or our backwards U's and C's based on those asymptotes. So let's go ahead and look at our first example. Again, remember the equation must be set equal to 1. So the first thing I need to do is adjust and divide everything by 16 here. Let's go ahead and do that first. So now I'm going to reduce the first fraction. It becomes 1/4. So I'm going to make it x squared over 4. Again, remember the hyperbola equation has a subtraction sign. And then here, nothing to reduce. And then the 16 over 16 becomes 1 whole. Now, if your test ends up being multiple choice, look for key things. If they're asking you to find out of the multiple choice answers an equation of a hyperbola and you see one with an addition sign, know that that's not going to be a possibility. So if you know the characteristics of what the equation needs, then it makes it a lot easier to eliminate bad choices. Now, again, let's take a look and give ourselves a quick visual of what we think our graph's going to look like. So you can see here that the top of the fraction is an x squared. So this tells me that when I'm all done, my graph should be touching the x-axis. So my final graph is going to look like this, the C and the backwards C, because I see the x squared on top of the first fraction. Notice it touches the x-axis. Now, let's go ahead and get the specific graph. We need to calculate our A, B, and C so we can find the vertices, the foci, and the asymptotes. So again, remember in this equation, the a squared doesn't move. So the a squared is always first. So a squared equals 4, and the b squared equals 16. So a squared will always be the first denominator, and b squared will always be the second denominator. I don't want to find just a squared. I want to find out what a equals, so I square root the 4. So a equals plus and minus 2. I need to do the same thing for the b, square root the 16, and I get plus and minus 4. I now need to find my c value. So I'm going to do the c squared equals a squared plus b squared. So for the hyperbola, the symbol in between here, or the operation, is going to be an addition sign. I'm now going to replace a squared and b squared from my original equation. So it's going to be 4 plus 16, c squared equals 20. I only want c, so c equals plus and minus the square root of 20. I need to break down the square root of 20. I can factor this. You can also do 2 times 10. But I'm going to go right into my answer. So c equals plus and minus 2 square root 5. Now, I now need to find my vertices and my focus point. So for the vertices, you always use the A. Now, one other thing, this standard form that we're working with, this is telling me since there's nothing being added or subtracted to the numerators here, this tells me that my center is at the origin. It's at 0, 0. Remember to find your vertices and your focus points. You take the center point and we're going to add this A value to the first letter I saw up here. So I'm going to be adding plus and minus, adding and subtracting 2 to the X of my center. So my vertices are going to be -2, 0, and +2, 0. Now, this graph does not have covertices, so now the only thing I need to calculate is the focus point. Again, I'm going to take my center, and I'm going to add and subtract my C value to the same variable I just did for the vertices, so to the x. So my two focus points are at -2 radical 5 comma 0 and +2 radical 5 comma 0. These are my foci, or my focus points. Now I also need to calculate asymptotes. That's why I found the value of b. So my asymptotes, those are going to be my lines, my equations, my linear equations. When the x squared is first, the equation is this: y equals plus and minus b over ax. So when the x squared is first, the b's on top. So I'm going to go ahead and write my equations. My b value is 4. My a value is 2. I can divide 4 by 2 evenly. 4 divided by 2 is 2. So my two equations for my asymptotes are y equals -2x and y equals +2x. The plus minus here. I'm going to break it apart into 2. Now, again, these equations are in y equals mx plus b form. Notice there's no b here, so my y-intercept, the b, is 0 because there's nothing. The number here in front, this 2, this is my slope. This is my b. So what I'm going to be graphing here is y equals -2x. I can turn this -2, the m, into a rise over run. So when I go to graph my asymptotes, I'm going to start at 0, 0. I'm going to rise 2 and run 1. So if I do the -2 first, I'll go down and to the right, or I could also go up and left. I'm going to connect the dots. That's my first asymptote. This is the equation y equals -2x. Now I'm going to do the equation y equals 2x. Again, I'm starting at 0, 0. I'm going to rise 2 and run 1. I could also go down and left. And here is my other asymptote. These are supposed to be straight lines. I'm not in Notability, so I can't hold down my stylus and make it straight. Now, next thing I'm going to graph are my two vertices. So I'm going to come over here to -2 comma 0 and +2 comma 0. Now, when we did the parabolas to make the C shape or the backwards C, we had to find an additional point. I'm not going to do that. I'm just going to use my red lines that I've graphed, the asymptotes, as my guide to know how fat or skinny to make my hyperbola. So I'm just going to take and go from the vertice and draw in my hyperbolas. The last thing I'm going to add to my graph are my focus points. Again, I could approximate this 2 square root 5. The square root of 5, if we weren't using a calculator, we would approximate it, know that it's in between the two perfect squares of 4 and 9. But I've got my calculator, so I'm going to go ahead and do this. So I'm going to do the square root of 5, and I get 2.2. I'm going to multiply that by 2, and I'm going to round this to about 4.5. So I'm going to be graphing -4.5 comma 0 and +4.5 comma 0. If it asks you to list the focus points, they're going to probably be listed in simplest radical form. So let me go ahead and add a few more tick marks here. So this is 3, 4, 5, 3, 4, 5. I'll put it in between. And those are my focus points. And my vertices were here. And that is your graph of your hyperbola.
Miss Corey?
Yes.
I think on the homework it asked for like...
So let's do domain and range here. So the range, notice the arrows on the end of these, it's going to go forever. So this is going to be all real numbers, or negative infinity to positive infinity. What's going to be different is going to be the domain, because it's not covering the entire x-axis. We have a gap here. So let's go ahead and cover that. So for the domain, we can see that it's going to go from negative infinity. So we're coming over through here, and then we're going to stop here, right here where the vertex is, at -2. And then we're going to union that with where we start up again, at +2 to infinity. But the range is going to cover all of our y's here. Again, we need this set equal to 1. So I'm going to divide everything by 100. So 25 over 100 is going to simplify to 1/4. So this will become y squared over 4. Again, a hyperbola has a subtraction sign. And then 4 over 100 will simplify to 1/25. And then 100 divided by 100 is 1. All right, so again, nothing being added or subtracted to the x squared, y squared. So this tells me my center is at the origin. There's no HK, or my HK is 0, 0. Then the next thing I need to do is my a squared, remember, is always first. B squared is always second. I need to square root the 4. I need to square root the 5. Or 25, sorry, and I get 5. So now I need to find my c value. C squared equals a squared plus b squared. Remember, it's a plus sign. So c squared equals 4 plus 25. C squared equals 29. Square root it, plus and minus the square root of 29. I now need to go back and find my focus points and my vertices and my asymptotes. I could put the asymptotes up here. So I need to calculate these things. So again, for the vertices, you take your center. And again, we're going to look to see which variable we see first. So I'm seeing y squared first. So that's what I'm going to add my a to the y. Add and subtract it. So my vertices are going to occur at 0, -2 and 0, +2. For the focus points, I'm going to do the same thing. Take the center, add and subtract root 29. So 0, negative square root 29 and 0, positive square root 29. For my asymptotes, when the y squared is first, we're going to be using this equation, plus and minus a over bx. So y squared, or y equals plus and minus, my a value is 2, my b value is 5. So notice the number here in front of x, it's already in rise over run formula. So when I go to graph these, my rise will be 2, my run will be 5. So let's go ahead and graph these, all these things that we just found, and then we'll find domain and range. So also remember, when it's the y squared first, your graph is going to look like the u and the upside down u. So let's go ahead and come up with that. Let's go ahead and get the vertices on here. So I've got one at +2 and -2 on the y-axis. So I have one here and here. I'm also going to graph my asymptotes. So I'm going to be graphing y equals negative 2 over 5x and y equals positive 2 over 5x. Notice my b, or my y-intercept, is 0, 0. So I'm going to rise 2. If I do the negative 1 first, I could go down 2 and to the right 5, or I could go up and left. Either way, connect the dots, make your first asymptote. Then I'm going to graph the positive 2 over 5x, up 2 to the right 5, or down 2 and to the left 5. Either way, remember when the slope is positive, it needs to rise from left to right. All right, I've got my asymptotes on here. Now I can use them as guides to make my graph. This is going to be a really wide or really fat graph. So again, just make your U-shape, skim along those asymptotes. Again, as long as everything's in the right spot, I'm not looking for precise, width on these. Just make them skim along. The other thing I need to get on here are my 2 focus points. So I'm going to go ahead and do the square root of 29. Remember, it's going to be in between the 2 perfect squares of 25 and 36. So square root of 25 is 5. So it's going to be 5 point something. It's actually 5.38. So I'm going to round this to 5.4 and negative 5.4. So if I come over here to my graph and I add in some tick marks, so 3, 4, 5, 6, 3, 4, 5, 6. I'll put it right about here and here. And those are the 2 foci. And that is your graph. So now let's go ahead and do domain and range. Notice the blue lines, they would eventually get wider and wider and cover the entire x-axis. So my domain is going to be all real numbers. However, my range, that's where the break is. So we're going to go from, for the range, it's going to go from negative infinity, and then it stops right here at the 2. We're going to union that where it takes off again at the positive 2 to infinity. And again, remember the infinities always get parentheses. Pretty good on that one? All right, let's try another one. Now what we're going to do is, with the center not at the origin, the next one. So these are the 2 setups. Again, remember the a squared is always first, and the b squared is always the second denominator. It's always set equal to 1. What changes is when x squared is first or y squared is first. And then what we're going to be adding in is this hk value. So the h always goes with x and the k always goes with y. Also, what's different is the equation for our asymptotes. This is the point slope form of the equation. This y1 is going to be your k. The x1 is going to be your h. And then the a and the b we're going to find from square rooting the a squared b squared. So let's go ahead and try an example when the center is not at the origin. Now, notice this one is already set up for me. It's already set equal to 1. So what I need to do here is find my h and k. Let's do that first. So the center, remember k is always with y, h is always with x. So my center point is going to be at -3, -2. Remember, when you pull it out, it's backwards of what you would think. Now let's do our a squared, which is the first denominator. Our b squared is the second denominator. The square root of 9 is plus and minus 3. And the square root of 4 is plus and minus 2. I need to find the c value so I can calculate the focus. So c squared equals a squared plus b squared. C squared equals, my a squared is 9, my b squared is 4. 9 plus 4 is 13. Square root it, plus and minus the square root of 13. Now, I can't break 13 down, so I'm just going to leave it like this. So now what we'll do is calculate the vertices, the asymptotes, and the focus points. Let's go do the vertices. We're going to take the center point and we're going to add this a value to this first variable, the top of the fraction, which is the y. So I'm going to add and subtract 3 to the -2. So my two vertices are going to be -3, comma, and I'm going to do -2 minus 3, so I get -5. And then I'm going to do -2 plus 3, so I get 1. So my vertices are these two ordered pairs. Let's do the asymptotes. I'll do it up here. Now, the equations that we're going to be doing, the y squared is first. So I'm using this formula, plus or minus a over b, x minus x1. So now remember, my y1 is going to be the k of the vertex. So this is h, this is k. So I'm going to be plugging in y minus -2. So I'm going to make this y plus 2. My a value is plus and minus 3, and my b value is 2. My x1 is my h, so it's a -3, so this becomes a plus 3. Now, when you're doing, if it's a standardized test and they list the asymptotes as in slope-intercept form, then you would need to distribute and combine like terms. But if they're just asking you to graph it, I'm not going to distribute this. All I'm going to do is take my center point when I go to graph it, which was the -3, -2, and then I'm just going to move from this center, this slope that's there. You're going to see it when I graph it. Let me go ahead and finish calculating my focus points, and then I'm going to put all of this on the graph. So again, my focus points use the center, and I'm going to be adding and subtracting the square root of 13 to the same variable I saw first, which was y. So my focus points are going to occur at -3, comma, -2 minus the square root 13, and -3, comma, -2 plus the square root of 13. So these are my two focus points. Now, let me go ahead and calculate what the square root of 13 is, just so I can see where approximately I'm going to put these. So the square root of 13 is actually 3.6. That's rounded. So I'm going to be doing this ordered pair. So I'm going to do -3. So I'm going to be doing -2 minus 3.6. So I get -5.6. And then this one will be -2 plus 3.6. So I get 1.6. Just so I have an idea of where I need to place those two coordinates. All right, so let's go ahead and get the vertices on here. I have a vertex here at -3, -5. So let me add some little markings here. So 4, 5, so -3, -5. I'm gonna come down here. It's one of my vertices. Then I have another one here at -3, +1. I'm now going to graph my asymptotes. So watch how we do it. So again, I'm going to take the center point. Let me graph that first. So -3, -2. I'm going to start there, and then I'm going to move from this point a -3 rise, and then +2 run, and then also the +3/2 rise and run. So from that point, I can just go ahead and move the slope, which was right here, up in my point slope. I don't need to distribute things and get it into y = mx + b form. So I'm going to rise 3. So 1, 2, 3, and run 2. And then I could also go down 1, 2, 3, and I could run 2. I can make my asymptote. And again, it should be a straight line. Again, now I'll do the negative. Rise 3, run 2. I could also go down 3 and over 2. Make your asymptotes. And now also put in your focus points, or let's go ahead and make the U shape. So just guide it along the asymptotes. And then now lastly, graph your focus points. So -3 and 1.6. So it's going to be really close to that vertice. And then the same thing here. And that was that graph. Oh, domain and range. Okay, so for the domain, remember whenever it's a U shape and an upside down U shape, the domain is all real numbers. The range is where there's this gap in here. So that's why we have the union. So the range is going to be it's going to go from -infinity. And then right here, it's going to go up to the -5. And I need a bracket. And I'm going to union that. And then it starts up again at +1 to infinity. One more example. We got 6 minutes. Everybody good? All right. Let's do this one. Now, notice this one doesn't have a denominator. So I'm going to put a 1 there because I need an a² value. So let's go ahead and pull the center point out. So again, this is H, this is K. So my center is at 3, 2. My a² is that 1 that I put there. So when I square root it, my a value is plus and minus 1 because the square root of 1 is 1 and -1. Then my b² is the 9. So b equals plus and minus 3. For my c value, c² equals a² plus b². c² equals 1 plus 9. c² equals 10. c equals plus and minus the square root of 10. I can't break 10 down, so I leave the whole thing under the radical. Now I need to calculate the vertices, the focus, and the asymptotes. So vertices, again, take your center. You're going to add the a value to the variable you saw first. So I'm going to add and subtract to the x. So I'm going to get the two coordinates are going to be 3 minus 1, which is 2, comma 2, and then 3 plus 1, which is 4, comma 2. These are my two vertices. My asymptotes y minus the k, which is 2. And now when the x is first, it's going to be b over a. So plus and minus 3 over 1. And then I put in the h, which is the 3. Now I can leave my slope. Hold on, let me let. Okay, I'm going to leave my slope as 3 over 1 because remember when you go to graph this, we're going to start at 3 comma 2, but then we're going to move from that point this slope of plus and minus 3 over 1. Pretty good on that so far? All right. So now let me calculate my focus points. Again, I'm going to take the center, 3 comma 2, and I'm going to add and subtract the square root of 10. So my two focus points are going to be 3 minus the square root of 10, comma 0, and 3 plus the square root of 10, comma 0. Now, I'm going to approximate the square root of 10. So square root of 10 is approximately 3.16. So I'm going to round it to 3.2. So for this first one, I'm going to be doing 3 minus 3.2. So that'll give me negative 2/10, comma 2. And then this one, I'm going to add it. So it'll be 6.2, comma 2. So that's approximately where I'm going to put my two focus points. So I have a focus here and here. So you'd leave it in simplest radical form. So let's put all this on the graph. Let's do the vertices. So I have one at 2, 2. That one. And then 4, 2. And right there. I now could graph my asymptotes. Again, let's graph the center. 1, 2, 3, 2. So right here is the center. And from that center point, I'm going to move this slope. So the number that was right here is how I'm going to move from that center point. So I'm going to rise 3 and run 1. And then the same thing for the negative. So I could go 1, 2, 3 and over 1. I could also go 1, 2, 3 up 1 or up 3 and over 1. So here is an asymptote, the negative asymptote. And then I'll do the positive, up 3 and over 1. I could also go down 3 and over 1. Connect the points. And now we're going to add in our graphs using those asymptotes as a guide. Notice it's really wide here. And then I'm also going to add in the focus points. So I have one over here at 2/10, comma 2, and then another one at 6. 1, 2, 3, 4, 5. I could add another point here and put it over here. And those are the focus. The domain. Notice this one's going to have the gap. So it stops here. So it's going to go from negative infinity, and then it stops at the 2, and then it picks up again over here at the 4 and goes to infinity. But the range is the all real numbers. So when it's the C and the backwards C, the range is the all real numbers. When it's the U and the upside down U, the domain is the all real numbers part. So there is a typo on the homework on the last slide. So you need to go by. Then on Thursday, I'll work out any questions you may have on this, and then we'll learn how to write equations for these hyperbolas. And then your homework over the weekend will be the test review. And again, we're considering giving you free response questions in addition to the multiple choice. Again, the test hasn't been finalized. We're working on it. Any questions? All right. That is all I have for you today. So I will see you guys on Thursday. Everybody good? All right, have a wonderful day. And I'll see you on Thursday. Bye. On Canvas, and you're doing 5 through 21 odd. And this is due on Thursday.